The World Health Organization announced a couple of weeks ago that within the next few years they expect more people to die from antibiotic-resistant bacteria than all of the cancers combined. Microbial robotics engineers microorganisms, viruses and bacteria, to do really big and important jobs for us. So we make them into living robots. So Sheng is working on MRSA, for example, and MRSA is obviously a very important organism. Some of them now have deep antibiotic resistance across the board. So now Sheng is looking at the antibiotic-resistant MRSA for potential therapeutic targets. Once he discovers what those drug target opportunities are, we'll provide those to researchers around the world, and researchers around the world can now develop drugs that will target his discovery. A lot of drugs fail to get into the market not because they're a bad drug, but because it's too expensive to develop them. So antibiotics are a great example. Many antibiotics are too expensive to develop, and the amount of money you make on it is too little to justify the big investment to do the drug discovery. So our approach is an open approach. Our goal is, instead of having a closed approach, which means everything is protected with patents and then you recoup the investment with a very high-priced product, rather what we do is open it, allow anybody in the world to develop it, and as a result of that, our investment's much lower, and the result is a much lower priced product. Tremendous advantage to the open model that we're pursuing is that not only can we help deliver drugs into the very rich nations that have insurance for their populations, but also into the very poor nations of the world. That's our venture. It's designed in Ohio and Kentucky by Microbial Robotics, assembled around the world by capable and responsible researchers and companies.